Every day, we humans turn thousands of tons of irreplaceable oil into chemicals and energy, plus carbon dioxide. We at Photanol in Amsterdam are working on a way to do it the other way around. We're turning carbon dioxide into green fuel and specialty chemicals using sunlight, creating a cyclical, sustainable chemical economy. To be fair, we're not the ones who thought of this first. 3.5 billion years ago, a primitive strand of bacteria called Cyanobacteria started using energy from sunlight to grow, using up carbon dioxide. This way, they became the inventor of photosynthesis. It was quite a hit. After all those years, cyanobacteria are still around in almost every environment, including the canals right next to our Amsterdam lab. Plants pretty soon stole the photosynthesis trick, and the rest is biological history. We decided to cooperate with this tiny inventor. We grow cyanobacteria in our lab reactor. They breathe in carbon dioxide and suck up light, and that's all they need to grow. But we wanted it to do a little more than just grow. Some other life forms, like plants, can make really complex, valuable molecules like lemon scent from carbon dioxide. So we decided to help our cyanobacteria. We gave them a full upgrade with plant DNA, so they can also make lemon scent. But we could have also chosen other upgrades and have them produce fuels, bioplastics, or almost anything else really. And in every case, they would be making it by using up carbon dioxide. And there's a bonus. From the cyanobacteria themselves, you can make a valuable, natural, bright blue dye. That's why they're called cyanobacteria. Of course, people have been using plants to produce foods, fuels, and specialty chemicals from sunlight for thousands of years. But as any farmer knows, you have to do a lot of work to grow, harvest, and process your harvest. Also, a typical plant produces a lot of waste materials that you can't easily use: stalks, branches, and leaves. Tiny cyanobacteria are much more efficient, working all year round, almost without producing any waste. They would need around 40 times less land surface than plants to make a comparable amount of products. In addition, they would need 10,000 times less water, so this doesn't have to be prime farmland. It could even be desert, sea, or wasteland, as long as you're not too far from a carbon dioxide source. For now, we at Photanol are concentrating on making valuable compounds, but cyanobacteria could also produce ingredients for bioplastics and fuels for energy, as well as specialized, complex molecules like cancer drugs. In fact, cyanobacteria can produce almost anything using almost nothing: water, carbon dioxide, and light. That's why we think they're the key to a truly cyclical use of resources. That's why we and our cyanobacteria are working hard to turn the carbon economy around.